Hi, my name is Steve Rahi. I am a Premier Field Engineer specializing in System Center Technologies. Today's discussion will be part 15 of an ongoing series talking about operating system deployment in Configuration Manager 2012. So part 15, we're going to cover a discussion of some random advanced topics, no particular order here, that we're going to go over. Kind of waited until at this stage in our discussion because these are advanced topics, some of them particularly are, and going over them requires the groundwork that we've already laid. So here's the things we're going to talk about. Some will take longer than others, some will be more or less just a mention. I want to talk about the pre-start command. We've already covered that whenever we went through the boot image, and I think I mentioned it before that as well. We'll go through it in a bit of detail here, show you actually how it works and some interesting things you can do with it. Standalone media, we'll hit that one as well, and probably won't take that much time on it, but I want to show you a couple of things about it. Branch cache, 1E Nomad, Adaptiva. Talk about some import issues that you can have with unknown systems. OSD web service, we'll demo that a little bit. And then I want to take you through a scenario that allows us to actually increase the speed at which images lay down. All right, so let's jump right in. So let's start with the pre-start command. So pre-start in Configuration Manager 2012, 2007, wherever, is a really useful thing. To refresh, let's actually pull in the lab and look at what a pre-start command is, right? So if we go into our boot images and look at the properties of a generic boot image, okay, under customization, we'll see the ability to enable a pre-start command. So this is what I'm talking about. And in this arena, just to stay here for a minute instead of going back, there's a number of things you could do. So it's just basically a blank slate that you can decide what to do. So you could run a DOS-based command here. You could kick off an executable. You could launch an HTA, right? Whatever. And then within those things, you have the sky's the limit, really, because it's code in many cases, and you can make it do whatever you like. So let's start. Well, before I show you a couple of these, just a couple of things about pre-start, right, that you need to kind of think about. So in customization, and what you're doing in pre-start, you can do a number of things. You might choose to run a PowerShell script, for example. You might choose to run an HTA, for example. Those are fine, but PE by default does not support PowerShell, and it does not support HTAs. And there may be other components that it doesn't. So you will have to add those pieces in. So you notice that I've added PowerShell here. You notice that I've added HTA support here. That's going to cause the boot image to actually regenerate, which will take a minute or two for sure. But then once you deploy and use this boot image, you will then have support for it. So if you're going to leverage PowerShell, leverage HTA commands, important to have those additional features as well. Also, in the Windows PE environment, there are some things that may not work as completely as they do in full running Windows. An example would be PowerShell. PowerShell support is great in Windows PE, but the kind of commands that you might want to use to establish a remote session with another system on the network, for example, won't work with the remoting styles that are in the later versions of PowerShell. You can do remote connections to systems in PowerShell using the classic remoting, if you will, where you supply the computer name and so on. You'll see an example of that in a minute. But understand that there could be differences in the way things work in Windows PE. Right. So also the command line that you use, you'll want to make sure that it's the right one. And generally that's pretty easy to do, but I'll show you the HTA one in a minute and the PowerShell one that I have set up in a minute and talk through some of those options. Right. And then some command lines could be standalone. You don't actually need any source content, especially if the script's already on a box or in a known location or whatever else. In other cases, you might need to embed content inside of the boot image. So in the case of running a PowerShell script, for example, you'll want to have that script So you will need to supply a source directory, so whenever we recompile the boot media, we'll have a place to go grab and pull that in and persist it. Right? So just like normal packages, in normal packaging, if you specify a source directory, or application for that matter, if you specify a source directory, that source directory needs to be the most specific path that it can be. In other words, you don't want to put an application on your desktop and then include the entire users folder. You want to be very specific to the folder where your application is located so that we have as little content to deal with as possible. Same thing here. So if you put your script in a larger scripts folder that has a whole bunch of tools, then we're going to carry those along inside PE. You may want that, you may not want that. So the suggestion would be take your script and put it in a unique folder so you can point to that directly and pull in just that content that you need. Avoids bloating the boot WIM and so on. Right? So there's another thing here that I'll show you because I'll leverage it in an example in a minute. In fact, I'll wait to that example to show it to you. All right, so still talking about the pre-start command. So the pre-start command is definitely something that you can do directly on the boot image. The thing to remember about that is if you define the pre-start command directly on the boot image, it will be in effect every time you use that boot image. Okay? You may not want that. It could be that you want to create a pre-start command that is unique to standalone media or unique to standard bootable media, so you're not actually altering the boot image. You're putting your command in your media. So if I pull up the wizard, I have several here. Standalone for sure has it. So customization, bootable media has customization. Capture media, sorry, it does not. Pre-stage media has customization, so on. So there are several media types where you have that same customization window. So the point being, you don't have to put your pre-start command on the boot image itself. You could define it on the boot image or the standalone media. I'm sorry, the boot media or the standalone media or the pre-stage media or whatever, and then it will be limited to when those media types are used. Right? Another thing that I alluded to a minute ago is the same customization window allows you the ability to inject variables. So we've talked about variables and using them in task sequences and how they work in OSD and things like that. Here is a place that it's really useful to know that you can add variables specifically to the boot media. Okay, so I'll probably say it again, but one of the examples coming up that I'll show you, I put on the boot media in variables my username and password that I want to use because I don't want to expose that in a PowerShell script or in a file maybe that I would create that has that in it. So I just embed it as variables on the media. That's cool because as long as they're in the boot media, we're booting that way, those variables are then available to our task sequence and it works beautifully. Right? All right, so best way to see this is actually to look at a couple of examples. All right. So first example that I have is a boot image here that I built custom that is configured to boot with an HTA. So if I look at properties, go back to customization, you'll see that I have, in fact, enabled that. Here's my command line for launching the HTA. So this is just a demo HTA that I put together, pretty basic. Not going to talk about how you build HTAs. It's a coding kind of thing that you would have to do, and it's not hard to do. But once you have it, you can launch it here. Now, this example, understand if you're launching an HTA as part of imaging, then by definition, you are in light touch imaging, right? Some real goodness comes whenever you get out of light touch imaging and into zero touch imaging, but if you're in the place where you need to use light touch imaging, you can certainly launch an HTA, let the user interact with whatever questions or options are in the HTA, and then proceed. Right? Notice that the HTA that I've used, here's the source path for it. I'm very specific to where I go to get the HTA, right? But in that, whenever I hit OK, we're going to go back, if it's the first time, and compile the media again, put it out on the DP. That'll take several minutes. Here, I'll just hit OK, and it's not going to do anything because I haven't made changes. So that's number one. So I went ahead and created a VM over here where I'm going to launch or startup with boot media that launches this HTA. So this pre-start command is directly on that boot media. So I'm going to start it, connect to it. It takes a minute to spin up for some reason here. And off we go. So we're booting. All right, and notice how this works. And I'll show you a graphic of this in just a minute. It looks just like a normal boot media, boot experience, right? This is an interactive boot experience because I'm going to have to make the choice of the image to run in just a minute, right? You can actually make this non-interactive, still have the pre-start command work and do whatever you want, right? But in this case, just to illustrate it, it's stopping me and I'm going to interact. So I'm going to hit next. And we're going to launch the HTA. Here comes the HTA, right? But notice what's happening here. So I'm going to actually close this window in the background. Notice that I'm basically frozen here. Actually, I think I went forward too quickly. Let me start that again. I'm going to reboot. All right. Let's do it again, because what should happen, what does happen, is while that HTA is up, and I know why it did it, I actually closed the command window. I didn't mean to do that. I was trying to grab the one behind it to pull it out. But while this HTA is up, the process does not proceed. We wait for us to click submit for the command window to close, and then we proceed, right? So let me do that again. So I click next. This comes up, HTA comes up, and we're frozen, right? Let me click back on here. We're basically spinning like we're waiting on something to happen, and we are waiting for something to happen. We're waiting to click submit. Here's the point, and I'll show it to you in a minute. At this stage, when the HTA has been launched, or when, said better, the pre-start command is initiated, we have not yet connected to the ConfigMgr infrastructure to ask for policy. Only after we hit submit here, it may error, it probably is here, I'm just going to close it to simulate. Only after we close that do we actually query the ConfigMgr infrastructure and proceed. So this should proceed in a minute. And then you have task sequences. The really cool thing about knowing how that works, the order at which it works, is since we don't retrieve policy yet, and I don't know why this is still spinning, but nevertheless, since we don't retrieve policy yet, our pre-start command has the ability to impact the result when we do ask for policy. Said another way, the pre-start command is very common when people use them. They will create variables. They might connect with the ConfigMgr infrastructure and add variables or whatever, create variables in the task sequencing environment, that kind of thing. That's cool because once we ask for policy and begin to choose task sequences, those variables are already in the environment, right? Those changes are already in the environment. And this is failing not because it really failed. You saw it run a second ago, but because I rebooted like I did. Okay, but point made. The other thing that I want to show you, let me go ahead and get rid of this, okay, about pre-staged, especially the HTA. So in this one, you have a couple of ways you could configure it. The way that probably many people will try to configure it is just to put in the name of the HTA, put in the package, and try to use it that way. And that does work, but it doesn't, right? So if you look at the logs, what will happen is you'll see that we're launching the HTA, and you'll see that we move right on, and you'll see that you never see it on the screen on the imaging machine, right? In order to make it show up on the screen, you have to prefix the call to the HTA with a cmd/c. In fact, if you go and search for pre-start command and HTA, you'll find a number of hits online. I wasn't able to find one that actually demonstrated how to do this in a pre-start command in boot media. I saw lots of examples where you could actually do a pre-start command kind of equivalent inside the task sequence. That's cool if you want to do it, or launch an HTA inside a task sequence. That's cool if you want to do that. Just remember, by the time you're into a task sequence, you've already pulled policy, you've already chosen the task sequence you want to run. So if you are okay with that, cool, do that. But if you want to have something that works before the task sequences ever even get queried, then you'll need to do it through boot media like this. Okay. All right, so that's one example. Well, what about an example where we run PowerShell? Well, this one is actually a pretty cool example, if I do say so myself. So here's the scenario. So I've said, I think maybe even in the series already, that it's very possible that you could use something like a pre-start command to completely automate the detection and build out of a system and essentially make it known after booting unknown. And since I've said that for a while, I figured I'll go ahead and build it out. And that's what this example is. So the scenario here, we will take a machine that is unknown, and I'm going to go ahead. I know that I have this machine in here because I was testing this. Let me get rid of it. So this machine here, these machines are all ones that I was testing with. I'm going to get rid of them, but you see that it's going to work because it worked there. Delete. Okay, so those are gone, or will be gone here very shortly. All right, go back to software library. Okay, so this boot image will allow a machine, or this pre-start command will allow a machine to boot as an unknown machine, and then through the script that's run, we'll do the work to basically figure out who that machine is and import it into the ConfigMgr database, and then move it to the right collections. And then once all that is done, the script ends. Well, at that point, we'll ask for policy. But we're going to be asking for policy for this machine as a known machine at this point versus unknown. So if you'll recall our discussion about known versus unknown, known is much more flexible than unknown in that you can set variables specifically on a machine that is known. You could have 5 or 10 or 20 machines that all had different variables because they are known quantities. In the unknown world, you have two choices, x86, x64. And yeah, you can do it within site too. But very limited. You can't set something specifically on a machine. You can set something specifically on an architecture, but not a specific machine. The same way, you could have collections of known machines in the known world, and the machines that are in that collection will inherit the variables and do whatever that collection defines that it should do, right? In unknown, you have one collection, unknown computers, and that's it, right? So definitely a lot more flexibility with known computers, yet with known, there's an assumption that you've had to import them into the ConfigMgr environment, and that's true, right? So let's actually look for a minute at this script, right? So what this script is going to do, here it is on my boot image. If I go to Properties, Customization, Customization, there we go. Here's the script. So I'm going to call PowerShell. I'm going to set execution policy to bypass for this script. I'm going to call the script right here. Right? And this PowerShell script will take over and do the work. Well, let's see what this PowerShell script does. All right. Here. Okay, so here's the script. And you'll notice that a couple of things. One, we're going to set up and configure the environment. This is a very basic script. You would probably want to add a lot more to it in a production environment, but this gives you at least the idea, right? So what we're going to do, I already mentioned that because I want to protect my username and password, I'm going to embed those items on the boot media as variables, right? That's in the customization tab when you create the boot media or standalone media or whatever. So in order to access those values that I'm putting as variables on the boot media, I need to instantiate the COM object for the task sequencing environment, right? Then I have a couple of entries that are statically assigned for my site server and my site code. In production, you might want to do this a bit more dynamic, but here I went ahead and used static. Since I'm importing this machine, I need to know what the machine name is, the local machine name is. So I'm just going to call out to my environment variables and get what the local computer name is. Now in this case, it's going to be a mini-nt generic Windows PE name. Right? That's really not a huge deal because your intention from here is to image the machine, and during imaging you're going to name it probably something anyway that you want it to be. The real key is to get this machine by GUID into the database, known, and in the right collection so you can target it with the right image or the right properties. Right? But if you want to name it the right thing here, you're certainly welcome to. From here, we're going to go out and connect to our task sequencing environment, get the user account password. I'm going to go ahead and convert it to a secure string here, and then create a credentials object. This credentials object is what I'm going to use to reach out and connect to the site server. Okay, so all that's done. Next thing I need to figure out the local MAC address. So this is a function that I wrote to actually go out and grab the MAC address. Okay, now I'm just doing one NIC. If you have more than one NIC, then you'll have to probably put some extra logic in here to choose the right one, do some testing, whatever, but this is how you would grab the NIC. After that, I'm just simply going to go through, this is work that I'm not yet using, but it's connecting to collections and so on. I'm going to go through and I'm going to create a new computer account in my site with the various attributes. So this is the old style remoting that I'm talking about, using a computer name switch and then passing the name of the, in my case, site server here. I'm also passing the credentials object because I'll need credentials to connect remotely to my ConfigMgr server. I'm creating a new record. I'm going to include the MAC address, system name, and so on. And finally, I'm going to create the record by invoking the method import machine entry. So this is actually on WMI. There is a method called import machine entry on the class that we reference, right? So this is very possible to do this inside Windows PE. Again, this is older style remoting, if you want to call it that, and so on. Once I have the machine imported, the rest of the script would go through to create a new collection rule, and I'm not finished with that yet. I'm still working on it. New collection rule, maybe a direct membership, update the collection, wait for the collection to show the machine in it, and then we release, right? And now the machine is known. So let's actually watch that work. So if I go back to my machines here and go to bare metal 2 and start it, so I've got my boot media that I created with, boot media I created with the boot image that I customized, and on that boot media I have the variables stored, and we'll leverage them here. And you saw me delete on the site server the machines that I had been playing with to import. So we'll let it do its thing. All right, so I'll just click next. You'll see PowerShell come up. You'll see it run, and then you'll see it exit. Pre-start command, running, and then it will close out in a minute, and we'll have a machine added at the CAS. All done. And then it's going to go through, and there we go. So if I go to the CAS, look back at my device list, come on. There we go, devices. Here is my machine that I just added. So from here, it's known. Off we go. Normal processes apply. Put it in the collection that you want. You can do that in code. And you can do a whole lot more in code if you want to, right? The only trade-offs, there's only really two challenges, one tongue-in-cheek, to creating a PowerShell pre-start command. One is every time you change the code for the PowerShell script, you have to recreate the boot media, because the boot media, or the boot image, I get those interchangeable. So the boot image will need to pull in the newer version of the PowerShell script. The command line may not change, but the script itself will, so it'll have to pull in the newer version of the PowerShell script so it's in there whenever you actually launch the boot media. That can get to be a bit frustrating because it's not a short process to update the boot image. So it'll slow down your testing. But that's really the only challenge with it. The other is that with any script, think of logon scripts that can be very long running. You don't want to cause the PowerShell script to run so long that it frustrates the user. Now, the idea here is that you're going to do this zero touch probably, so the user won't even be impacted. But still, things to think about. All right, so let's go back to the PowerPoint for a minute. Pull the lab back out, and go on. So this is just me showing you kind of how this works behind the scenes. So you saw me start in this screen, and then I click Next. This, I don't have really a pre-start hook to do, but just to show you here, we're actually looking for it in the tsconfig.ini, which I'll show you that in a minute. Forgot to keep that up for that, so let me go. No, I do, so I have it up. So in the tsconfig.ini, that's where we store our path to whatever command we have in the pre-start. And then down here, we're starting to retrieve the client identity. We don't even know what the client identity is yet. And then below here, we're going to start to get policy. So up until the time the hook runs, until here, we haven't even contacted the config manager infrastructure. Once the hook finishes, or the process finishes, then we go to this screen and get to choose task sequences. Right? Well, imagine if you want, again, with our example here, if you're trying to make an unknown computer known, the list of task sequences available to a known machine could be very different than the list of task sequences available to an unknown machine. The list of task sequences available, given the conditions of boot, maybe in a certain part of the network or whatever that you detect, could be different. Right? So the sky really is the limit here. So before I go on, let me just pull this in to show you real quick because I did keep this running. So if I press F8 to go to the command prompt, come on, F8, and just go to the root of the X drive, there's this tsconfig.ini, and this is where we actually store the command line for the pre-start command and then the source directory that we're using. Right? So just a little bit of knowledge there. Okay, we'll turn that off now and pull the lab back out. All right, so just did the demo, right? Walked through it, showed you how this works, and that's really it for pre-start. It's pretty cool, though, right? Knowing how that works and the pattern, the flow of it, pretty good stuff to help maybe bring some goodness to the environment. Okay, so the next one is next topic is standalone media. So standalone media, we've talked about, right? Standalone media was designed to provide imaging services to machines that are disconnected from the network. But does that mean that the machines that run the standalone media wizard, the standalone media, does that mean they're not going to be able to use a network connection? Or in other words, is the standalone media going to prevent the machine from connecting to the network? And the answer is no, right? So if you don't have a network connection, so you have a machine unplugged from the network, standalone media works beautifully, will allow imaging, no problem, even if you cannot get to the network. That's the point of it. But if you do have an active network connection, then we'll initialize the NIC, and you can make use of that in your task sequence. Right? So it's a little bit of a different way of thinking about standalone media. There could be some scenarios that it applies, right? So there are a few example scenarios that might illustrate the benefit of doing an approach like this. One of the so one scenario might be that even though you're using standalone media and you want to avoid hitting the network for your image and your packages and things like that, maybe it's important to you that you have these machines patched. Well, there's a couple of different ways to do it. You could use install updates offline, which is an MDT edition. Works great, right? And it does give you a package, so that would be included in the standalone media. Or you could just say install software updates, which uses the config manager agent to go out and reach to the config manager site server and try to do it that way. Since we have a network connection, I've never really tested that, honestly, but it should work because we're just going across the network, right? Another example might be if you want to have a single task sequence that deploys any image that you have in your environment, and just give that task sequence to your staff, your technicians that go service machines, and let the task sequence just image whatever's needed. That's possible. So one of the customers I work with, for example, has a single task sequence that will allow them to image Windows 7, Windows 8, or Windows 8.1. Right? And that's all decided through the logic of the task sequence. The standalone media is fairly large because it has to package up all of those WIMs. But the point is it's self-contained, and they understand the limitations of that, and they're quite happy doing what they're doing, right? And that's a point. We offer all of these choices for you. There are some options that won't work or will work depending on what you do, and some challenges you will or won't have depending on what you do. So that choice is really up to you. But standalone media, while not traditionally used, task sequences really aren't traditionally used to package up, multiple WIMs. It's very possible to do so and can solve some interesting business cases. Right, a third scenario. So let's say that you have a remote office, very slow network connectivity, and you need to migrate machines from one OS to another. So a very recent occurrence would be migrating from XP to Windows 7 or 8. And you want to preserve user state while you do it. What you don't want to do, though, is worry about having to time it out with running the ConfigMgr piece to actually do the user state capture on a live machine, right, and have the user do it. So you might want to have your technicians there doing it. One of the things you can do is use standalone media to grab, using USMT, all of your user state and store it on a local hard drive at the office, a local server at the office, whatever. It's your own creation for USMT because the normal steps may not even work for you, may not fit your bill, right? You could use them, might not, may be custom. But the point is you can use the standalone media knowing that it has a network connection to store the user state on a local server. And then you can have a completely different task sequence that's on standalone media to image bare metal machines and engineered to go grab the user state from whatever network location you've stored it on, right? Again, more examples you can come up with. I've seen people think through and try to use this as kind of another way to accomplish pre-stage, and it was kind of an interesting scenario. But just knowing that you actually do have network connectivity offers some options to you in terms of which way you go. So let me just show you that real quick. Pretty simple and easy demo. Get rid of this guy. So here we have our standalone media that I created. I'm just going to go ahead and start this thing, let it boot. Come on. All right. And here we go. So the whole point of this demo is just to simply open up the F8 command prompt. I'll show you that this is standalone by just clicking next here. Okay, good enough. So I'll click next. This is standalone media just because of what it does right here. But if I hit F8 and simply do an ipconfig, you see that we have an assigned IP address. Right? So if we were not initializing the NIC, first of all, the NIC wouldn't even show up here. And if we didn't have DHCP, it would have a 169. So that's the point of that, is just to show, in fact, we do initialize the NIC. You can then use it accordingly. All right. Cool. So let's get rid of that one. Okay, so this we'll touch really fast, right? So not really a topic that, I guess I could spend up a whole session talking about Branch Cache, 1E Nomad, Adaptiva. Those are third-party products, two of them anyway. And they all three essentially do the same thing. So the whole point of these products is to allow you to have a local peer or set of peers act as a distribution point in a slower network. So if you want to avoid having to place a dedicated distribution point in an area of the network that's slow and instead want to do peer caching of content, then any of these solutions are great to be able to provide that service, right? There are advantages to 1E Nomad and Adaptiva, adding some additional bells and whistles and things, but Branch Cache works just beautifully, right? But what about Branch Cache, Nomad, or Adaptiva in terms of OSD? Branch Cache does not support, Windows PE by default is not Branch Cache aware. And that's a big deal for OSD. Why? Because in the Windows PE phase is where we're moving a large amount of content. So that's where we pull the WIM, that's where we get driver packages, that's where we get some other things potentially, right? So the fact that it's not capable of using Branch Cache in Windows PE is a bit of a limiting factor. The good thing is, completely unsupported, but the good thing is that there are ways to add Branch Cache support into Windows PE. So even in the Windows PE phase, we can reach out to peers on the network and pull WIMs and so on if they have them. Makes the experience much faster. Again, not supported because it's not configured that way out of the box. So if you choose to do that, there's articles that will tell you how to do it, but just use at your own risk, right? 1E Nomad, Adaptiva are engineered to work with Windows PE in that phase, and they do quite a nice job, right? So if you are in a situation where you would benefit from using a peer caching technology like one of these, definitely recommend it. Not specific only to ConfigMgr, but certainly ConfigMgr makes really good use of those technologies if they are present. Certainly Branch Cache isn't ConfigMgr specific. All right. Import options for an unknown system import. So we've talked about at a bit of length that if you want to make a machine that is unknown known, you're going to have to import it into the ConfigMgr database, right? There are a few ways to do that. So I've already showed you this in a previous session, but just to pull it back in for a minute, if I go to my CAS and look, here's the import computer information wizard that I demoed back then, I'm sure, where I can either use a file to import multiple computers or go one at a time and import them that way. In either way, this is sometimes more of a challenge than it could be, right? A challenge in that you have to get the file from somewhere, or you have to run through this multiple times to do the computer import. So most people who, or a lot of people who actually do computer imports will automate that process. Well, how do you automate it? One way would be to use something like, Orchestrator would be a good way to connect in with maybe a web form or something like that. And whenever you get the information about the machine that's about to image, it'll go ahead and create the import for you on the fly, right? Lots of tangents you could take off of that. The other is just the script that I showed you live in the pre-start command. You can do all of that just automatically when the machine boots, right? Unknown. And there could be variations off of each one. Okay, but in an enterprise, you're probably going to want to automate this in some way, shape, or form. Okay. When you do this, when you are working with known systems, all right, which is the result when you import, the way we look up and determine if a system is known is by looking up either the MAC address or the SMBIOS GUID, UUID. There's challenges with that because if we have duplicated MAC addresses, duplicated SMBIOS information, then the experience with OSD will stop a little bit short, right? So said another way, whenever we're looking up a machine by MAC address or by SMBIOS information, we expect there to be exactly one machine with that identifying information in the database because that's the way it should be. So the very first machine that we encounter, we assume is the one that we're looking for, and we stop. If the task sequences targeted to that machine are different than the ones that we expect, then it's going to be a bit weird for imaging. If, in fact, there are no task sequences targeted to that machine because it's the wrong machine, then we're going to fail every time, right? So making sure that your information in the database is consistent is really important. So how could you get into a situation where you have multiple MAC addresses across machines, right? A good example would be, especially with the tablets that we have in the world today, Ethernet dongles. So that would be Ethernet ports that plug into a USB port on a tablet, and on that dongle it's a full Ethernet port with a MAC address with all of that information assigned. So when you plug it into the first one and then attach it to the network and image it, everything's fine. But then you take that dongle out, put it on the next tablet, and start to try to image it. Guess what? The MAC address and such on that dongle is now the same as the one you just imaged. And so it's going to potentially cause confusion for OSD, right? Because we might find the wrong machine, think it's already imaged, and so on, right? Could be also if there's shared docking stations or whatever that are used during imaging, that could also lead to the problem. I recall back in earlier versions of Windows, there was the dial-up adapter, and all of the dial-up adapters had the same MAC address and so on. So if you do have duplication of that arena, and you're trying to image a machine so affected, it could be strange results, right? So it's good to be able to know what machines or what MAC addresses might be duplicated. This query will actually tell you what MAC addresses have more than one instance in the database, right? You could easily craft this query to look at duplications of other items too, but this one is specifically for MAC addresses, right? All right, so, go forward. The OSD web service. So this is one that I came across recently. It's actually really pretty cool, right? So a web service basically is a website, big surprise, that essentially takes information from a caller and then passes that information or uses that information to run functions or whatever else that are defined at that web service. In this particular case, notice this is third party, the one that I'm showing you the link here, so just be aware it works beautifully, but it is third party. In this case, it was engineered to work in the MDT ConfigMgr environment, and the reason it was built is because of that limitation that I talked about in Windows PE. Up until just recently, the last couple of versions of Windows PE, there was zero support for PowerShell in Windows PE, right? And so you couldn't even write a PowerShell script and make it run in Windows PE, but yet we had a need in the imaging world to be able to interact with the ConfigMgr environment to do so in a fairly easy way, the kind of way that PowerShell provides. So what the folks here did is they created a web service that in Windows PE, other places too, but certainly in Windows PE, you can call out to that web service to ask for it to do certain things, like add a computer, like, as we'll see in a minute, clear last pixie, add a computer to AD, or different things, right? And it works very well. So in my case, where I wrote PowerShell, it's code that's reaching out across the network, connecting to remote WMI, and so on. And that runs as a pre-start, right? Or you can run something similar as a run command, run PowerShell, whatever. Here, you don't really even need the code. You can pass all of the information, including the function, including all the parameters that you need and so on the URL, right, that you call. So inside a task sequence, you would be using the run command line option, and you would just type out http:// all the way through, including all the functions you need, all the parameters, and that would hand off to the web service. The web service would just do its thing, right? So that's kind of why also to use the web service, to act as a middleman, to make things easier so that you don't have to spend a lot of effort coding. You can just leverage this big code repository, if you will, to do the work, but it's on a website, right? So let me show you this for a minute. I want to just show you how to set it up, what it is, how to set it up, and so on. So let me pull the lab back in. Here's where I have it, right? Let me minimize this for a moment. So this right here is the downloaded web service application. It's just like this. This is the way it's expanded from the zip file. A couple of things about it. First, these are all the binaries that you need. You'll see that there's a couple of different ways you can call it. You can call it with the SCCM extension for those particular functions. You can call it with MDT functions or AD functions or whatever. I'm going to use the SCCM. Okay. In order to make use of this web service, you're going to have to create a place for it in IE. So easy enough, just on the default website, you can add an application. You point to, or give it an alias, in my case, MDT Web Service, point to the physical path of the folder, which is here, right? Now, in order for IIS to see this folder, you're going to have to give rights to an account that can access this folder, right? In my case, just to make it easy, I gave everyone read access to the folder, but you'll probably want to do something different in production, right? Now, this web service actually runs as an application pool. So it's going to be added to an application pool. The default one is normally where it's at. I go ahead and move it to its own app pool. And the reason I do that is I want to set up security on the app pool so that I know what account is being used. So this app pool is what's going to reach out to ConfigMgr, and the credentials here need to have rights in ConfigMgr. Okay. There's another little piece here that you need to do, and that is actually configure the web service so that it knows what site to connect to. So let me pause this for just a second while I pull that up. Okay, I opened up the web.config. The reason I wanted to pause is this password that I had configured here was plain text. I didn't really want it to be, so I wanted to go ahead and put asterisks here. In your case, you will have a visible password, so just know that, right? That's why you want to permission this well, so that it's protected. But this configuration information, your site server, your SLP, which management point, whatever, site code, all this information you'll want to put in to allow the web service to know where to go when it's running functions. Okay. So let me just pull this up for a minute and look at it. So if I go to my browser, so a couple of them I'll demonstrate. There's a number here. So localhost, DT, web service, and I'm going to do sccm.asmx. All right, so that's going to pop up. And now, this is not the way you would use it. You would use it by calling the URLs from a task sequence or whatever, but just to demonstrate it, I'm going to use it from here. These are fully functional commands. There's quite a number of them, as you can see. I'll do 3 of them. So add computer. So I'll just give it a MAC address of all ones. Oops. I hit enter too soon. And by the way, a result of 0 means it failed. Okay. There we go. No surprise that one failed. So I'll call this test system. And I will give it the site code, PR or PS1, and invoke. And so it's going to go and try to add that system. And indeed, we got an item key back, or a reference number for the machine, and so we know that in fact worked. If we go to our console and look, you'll see, just refresh it here to make sure, that we have test system there, right? So it in fact did pull that up. All right, so a couple more. So let's go ahead and close this down. Go back to our list. Here's one that is very useful in some scenarios. This Clear Last Pixie advertisement for a collection. So important if you want to allow a system that has previously Pixie booted to boot again, you're going to have to clear the last Pixie advertisement. This will do it for you. Okay, so let's just do all systems and PS1, and we'll get back a true, which means it's good at this stage, right? If it didn't work, it would be false. And then we can even do something like list all computers. I'm not going to run through all these commands, just a few to show. Search computer names. So I want to pull back all that begin with lab server at PS1. And I'll get a nice list in XML form of these machines, detail about them, GUID, and so on. So pretty useful, right? And then there's the modules specific to MDT and AD and such that I don't have. Right? Again, third-party, user at your own risk, certainly worth investigating and taking a look at, and I just wanted to show it there. Okay. Last topic. So faster imaging. Imaging is a process by its very nature that does take time. And finding ways to make that time go by faster is only a good thing. So recently, one of my colleagues was working on the Windows 10 testing and different things, and I forget where he actually saw it, but it's really become a big deal. Actually, there's a blog entry there from the deployment guys talking about this process and well documented, right? And the results they've found is that you're going to get about a 30 to 50% increase in imaging speed. The reason is all about this tool called PowerConfig. So PowerConfig is a utility that's been around since, I believe, even Windows XP. I don't think it's before that. And it's a command line that allows you to specify what power scheme you want in place on the system that's running, right? The nice thing about PowerConfig is the GUIDs have remained the same throughout all of the versions of the OSs. And what we found is if you put your system into high performance mode, your performance on imaging will increase pretty notably, right? You might be a little bit less than that, but even 15 to 20% gain is a pretty substantial gain and probably worth the extra work, right? So the idea, again, is to add PowerConfig in various places throughout the task sequence. If we reboot, we're going to have to reestablish PowerConfig, especially in PE and so on. Maybe different places even in the running OS, right? The blog walks you through all of it. The blog, though, is centered on MDT. It's pretty easy for a config manager person to take the instructions for MDT and actually apply them to config manager. That's what I've done here, right? So I'll show that to you in a minute. The other thing to note about this is if you're imaging VMs, which that's done a lot in the server world, your throughput is not going to be really increased that much, right? Because in most VM environments, the power configuration options are disabled on the VM host, and so you're not going to really get that much more benefit. The other thing is you might not see as much benefit if you're coming across a network where your speed is more the limiting factor than it is the performance of the machine, right? A good way to test this, as an example, to see what kind of real increase you're getting is to create your task sequence without power configuration and do a standalone media option for imaging it, time it, and then configure it for power config with high performance. Do another standalone media so the network is completely out of the picture and see how the difference is, right? All right, so that said, let me just pull this in. I'm not going to really demonstrate this, not a ton to demonstrate, but certainly can work through it here. So if we go back to our CAS, where I have this defined, software library, what you'll see in my task sequences is an imaging speed demo. So this is just a standard task sequence for imaging a machine, but I've inserted setting to high performance, right? Here's my power config, right? Here's my package. Now, what you'll want to do probably in production, if you have any x86 boxes, is create your package that contains both an x64 and x86 version, and then on the command line, point it to the right architecture using something like the environment variable %processor architecture %, or processor underscore architecture %, right? You can still do it in one step, but I just went ahead and used the 64-bit because all of mine are 64-bit. All right, and you'll notice that there's multiple of these steps throughout here, and they're all the same, except for the very last one. In this case, it's the same, but the very last one is where we can influence what the production settings are for power consumption. All right, so here, the very first thing I'm doing is to set the power configuration, right? The first section only runs if we're in a re-image type scenario. We're going to do things like scrape user data and so on. That can be fairly disk intensive too. So setting power configuration to high there, you'll get some gain as well. If you are starting bare metal or once you boot into Windows PE, we're going to basically wipe the disk and start over. So I'm setting my first power to high performance after the partitioning. Why? Because on bare metal systems, the disks won't be initialized necessarily. You can't depend on them to be initialized. And even if they are, they're going to be formatted. And so you want to put your power config step after the format and partition so we have a place to download the content that will remain throughout the rest, right? If you put it before the format and partition, you'll get errors. All right. So after we reboot into PE, we're setting it again. Then we're doing all of our PE stuff. Once we reboot out of PE, then I'm setting it again, right? And if I were to reboot inside PE for every reboot, I would need to reset it. Then restarting inside Windows, generally speaking, the power configurations will hold. If they don't, after a restart, you can reinforce them. And then finally, at the end of it, I'm going to set it to what its running value should be. And that's really it. There's some edits you can see, I believe it's on the blog, about modifying the unattend file and different things if you want to go to that level. But give it a shot. It's not that hard to work with that, and the performance gain you get will be worth it, right? And it's at this blog if you want to go take a look. And that's really it. A few advanced topics, no particular place to put them in a different session necessarily, but worth talking about and builds upon some of the things we've already laid a foundation for. So we'll wrap this session here, and we will see you next time for session 16.